Hello students, and welcome to the next module for the chapter sequence and series. I hope you are enjoying these modules, and if you are enjoying, do let me know by commenting and liking the video. So in this video we are going to see the pointer number 6, that is means topic in sequence and series. Let's go ahead. Alright students, so in means the first pointer is arithmetic mean. Now arithmetic mean is something that we have already seen in schools. For example, let us say there are two numbers, one is 3 and other is 7. Okay, now in schools if we are supposed to find mean of these two numbers 3 and 7, we used to do 3 plus 7 upon 2 and the answer was 5. Yeah, so 5 is called as a mean of 3 and 7, right? Now this mean exactly refers to arithmetic mean in the chapter sequence and series. Okay, now students, see the definition of arithmetic mean. If I substitute this 5 or if I put this 5 in between 3 and 7, then do you see the three numbers 3, 5, 7 are forming an arithmetic progression? Okay, so they form an AP, and exactly this way we define arithmetic mean. So definition of arithmetic mean is if three numbers x, a and y form an AP. So students, you focus here. If three numbers are forming an AP, then the middle number a is always called as arithmetic mean of x and y. And the formula to find a is we use a is equal to, just like average, x plus y divided by 2. Okay students? Similarly students, there is another definition called as geometric mean. Now, if three numbers x, g and y form a GP, that is geometric progression, then g, middle number, is called geometric mean of x and y. Okay students, let us try to understand with quick examples. If three numbers, as we saw, 3, 5, 7, they form an AP, right? And hence the middle number, this 5, is called arithmetic mean. Okay, now here for geometric mean, if we take 3, 6 and 12, if you see, common ratio is 2, so this is a GP, geometric progression. If three numbers are in GP, then the middle number is called as geometric mean. Okay, the third definition is harmonic mean. Now harmonic mean is again similar students. If three numbers x, h, y form a HP, then h, that is middle number, is called harmonic mean of x and y. To see an example, let us take three numbers 1, 1 upon 3, 1 upon 5 and 1 upon 7. As you have watched in previous module, these three numbers form HP because their denominators form AP or their reciprocals form AP. Okay, so if three numbers are forming an HP, then the middle term is called harmonic mean. Okay students, now let us see relation between means. So far what we have studied is A, that is arithmetic mean, is given by x plus y upon 2. Okay, geometric mean G is given by under root xy, and harmonic mean H is given by 2xy divided by x plus y. Right students, now let us try to establish some relation between them. Now if we see this H can be written as H is equal to 2 upon x plus y into xy. Right students, now if you look at this part, 2 upon x plus y, this 2 upon x plus y is a reciprocal of arithmetic mean, so we can say this is 1 upon a, right, into, now have a look at the second term, it is xy, this xy is g square, we can easily say that, so here I write g square. and hence we can prove that relation between three means is g square equals ah. This one is very important relation when we solve problems based on means. Now, apart from this relation, we can remember one more relation here, that for any two positive numbers x and y, we can always say that arithmetic mean is always greater or equal to geometric mean, which is always greater than or equal to harmonic mean. So this condition always holds for any two positive numbers. Okay students, now let us proceed. Okay students, next topic that we will learn is related to problems based on means. It is insertion of means. So let us understand this through a question. The question here is insert four arithmetic means between the numbers 5 and 20. Okay, so we want to insert four arithmetic means between 5 and 20. Let us see the solution. Let the four means be A1, A2, A3, A4. So we assume them as A1, A2, A3, A4. Now, as per definition of means, guys, 5, A1, A2, A3, A4 and 20 are in AP. So means form, arithmetic means form AP. Yeah. So we say there are six numbers are in AP. These are total six numbers, including end values also. So six numbers are in AP. Okay. Now these six numbers are, first term is 5, T2, second term is A1, T3 is A2, T4 is A3, T5 is A4, T6 is 20. Now students, out of all this, which one we can use is this T6. So we write T6 is equal to A plus 5D. We know T6 value, we know A value, we get the common difference. So common difference is obtained as 3. Now as we have value of first term and common difference, we can calculate the second term of AP, T2, and this T2 is first arithmetic mean. So T2 is A plus D, that becomes 8. Similarly, we can get T3, that is second arithmetic mean, and hence we can get third and fourth. So the four arithmetic means are 8, 11, 14 and 17. Okay students, now let us see another technique to solve the same question. So here I have written entrance shortcut below the same question. Now see the shortcut. If n arithmetic means, so n means are inserted between two numbers, two positive numbers x and y, then any arithmetic mean AR, R can be anything, that is A1, A2, A3, is given by AR is equal to x plus R times y minus x upon n plus 1. Okay, let us see what this gives. Let us have the first arithmetic mean A1. So A1 will be equal to x and y. For our question, x is 5 and y is 20, right? So it is 5 plus r times. So r is 1. So 1 into y minus x, that is 20 minus 5 divided by n plus 1. N is 4 because we are inserting 4 means. Yeah. So n plus 1 is 5. And this gives us 5 plus 3, that is 8. So in this way we can directly find arithmetic mean in a very fast manner. The second arithmetic mean would be again x5 plus second, so we use 2, y minus x upon n plus 1 remains as it is, and this gives 5 plus 6, that is 11. Similarly, A3 would be 5 plus 3 times this bracket 20 minus 5 upon 5, that is 5 plus 9 equals 14, and fourth arithmetic mean would be 5 plus 4 times 20 minus 5 upon 5, that is 5 plus 12, that is 17. So for entrance, students must by heart this as a shortcut for arithmetic mean. Okay students, so here is a list of shortcuts that you can use to find arithmetic mean, geometric mean, or harmonic mean directly. Let us go through them. The first one we saw very clearly. This is for arithmetic means. Have a look at the second one. If n geometric means are inserted between x and y, then any geometric mean gr, any mean you can find out using the formula gr is equal to x times y upon x, the complete bracket raised to r upon n plus 1. R is here the number of mean that we are finding. N is number of means we are inserting. Okay, and then we can get each mean using this shortcut. The third says if n harmonic means are inserted between x and y, then any harmonic mean hr is given by hr is equal to xy into r plus 1 upon rx plus y. Okay. Okay, students. Similarly, there are some shortcuts to find arithmetic mean, geometric mean, and harmonic mean for n numbers, where numbers can be any a1, a2, a3 up to an. So if you have 5 numbers, these formulas can give you arithmetic mean, geometric mean, and harmonic mean of all 5 numbers. If you have 10, again you can use this formula. Okay, see the formula. The first says arithmetic mean of n terms a1, a2, a3 is addition of all terms divided by n. Second says geometric mean of all n terms is g equal to a1 into a2 into a3 up to into an product whole raised to 1 upon n. So if you have 3 numbers, it is 1 by 3 power cube root. Okay, as we have seen it for 2 numbers, we took square root. And in general, harmonic mean of n numbers would be h is equal to n upon 1 by a1 plus 1 by a2 plus 1 by a3 reciprocal of each term. Okay, so here we complete this module on means. If I hope it was useful for you. If you like it, do subscribe the channel. Thank you.